Hi guys, welcome to the channel. Don't forget to smash
Don't
that
you
like
have a
button.
YouTube channel?
I do have a YouTube channel. That's where this is gonna go. I'll just put this on YouTube. Okay, cool. I used to teach this a different way and it was like kind of helpful. I've learned a better way to teach this that I think will make more sense. So again, for those of you that already understand this, this might seem like overkill, but what I want to do in teaching you how to change, so like, just so we're clear on what we're talking about, right? If I give you like 546 grams, I want to know how many milligrams that is. Right, that's the kind of, that's what I mean by a metric conversion. I'm converting between two metric units, okay? What helps us understand things better is if we can connect them to other things we already know about, okay? So I'm gonna take this idea and I wanna connect it to a lot of different math things that you've seen. And when we have a collection of ideas that all relate, your brain does a better job of remembering it. As opposed to me being like, here's the one way to do it, just do that and don't forget it. If I just give you one random thing, it's harder to keep it in your brain. If it's connected to other ideas, it sticks better, okay? So, allow me to continue with this, and let's start by making a graph, okay? And I'm gonna make a point with this, okay? Let's compare a base unit to any prefix, okay? Someone pick a base unit.
Grams.
Grams, great. We'll do grams. Okay, I'm gonna make a little graph with like 5 points on it. Okay, it doesn't have to be too precise. Someone pick a unit related to grams that has a prefix. Kilograms. Okay. Actually, for the sake of this graph, let's pick one smaller than grams. Sorry. So pick one that's smaller than grams. Micrograms? Sounds great. Micrograms. Okay. I could do it the other way, but I would have to flip stuff and I didn't want to deal with it. Okay, so let's say I have 1 gram, let's say I have 2 grams, 3 grams, 4 grams, and then 5 grams. Okay? If I have 1 gram, how many micrograms do I have? Would be equivalent to that mass.
Like 1,000.
More than 1,000. Someone mumbled it. 1,000,000. Yeah, 1,000,000 micrograms. If you check your notes from the other day, we had 10 to the negative 6, right? So if we flip it, in 1 microgram, there's a millionth of a gram. Or if you have 1 gram, you have 1,000,000 micrograms, right? It goes both ways.
Can we start with deci and like go down the list?
Say what?
Can we start with deci and go down the list?
We're just doing micrograms. I just want to compare micrograms and grams.
Oh, like, okay.
Yeah. But I'm going to make a point from this, okay? So if I had 2 grams,
2 million.
I have 2,000,000 micrograms. Okay, I'm starting really easy, but we're going somewhere with this. Wow, this marker is terrible. Can you fill in the rest of this chart probably?
Yeah.
Probably can. 3 grams is 3,000,000 micrograms. There we go, that's a marker. 4 million, 5 million. Okay, so we could graph this. 1 gram, 2 gram, 3 gram, 4 gram, 5 gram. And we'll go by millions, right? 1 million, 2 million, 3 million, 4 million, 5 million. Okay, so this is my grams. Here's my micrograms. What's my graph gonna look like? Anyone know what shape it's gonna be? Straight line, yeah, it's a linear graph, right? So 1, 2, 3, 4, 5. And we'll just say this is in millions. Can I write sideways? 1 million, 2 million, 3 million, 4 million, 5 million, right? Perfectly straight line. And it goes through all the points perfectly. Yeah. Okay. Question. Let's say I take my micrograms and I divide it by the number of grams that is equal to that. So let's say I have 1,000,000 micrograms, right? I'm gonna take this value and I divide it by this value, what do I get?
1 million.
I get 1 million, right? Equals 1 million. I'll just put 10 to the 6, okay? Now, is that only true for this point? For this point right here?
No,
What if I did that same thing with that point?
this is the same.
Well, so here's the funny thing. It's not the same thing. 2 million and million are not the same thing. But what is the same? 2 million divided by 2 gives me what? 1 million. So the individual numbers are different. So this is micrograms, this is grams. But the ratio is the same. Yes?
Yes.
See that? I could go all the way up to this decimal point. If I had 5 million divided by 5 grams, what do I get?
5 million or 1 million.
I'd still get 1 million, right? Same. The ratio is the same. The ratio of micrograms to grams is the same no matter the exact amount you have. Yes? Okay. Now this might seem like 6th grade math, or maybe it doesn't, okay? But we're gonna build off of this, and we're gonna use this idea of ratios to kind of wrap our brain around how we can convert these real quickly, okay? So this is a way to represent this idea using a graph. Let's represent this same idea using words. Okay, we've got graph, now let's use words, okay? A way I like to describe this in words is by using something called a for every statement. For every statement, okay? And so the way we can describe this relationship is by saying something like, for every blank micrograms, there is blank grams. Right? I can take this ratio and put it in words. Right? We're translating fractions into words. Okay? I'm trying to connect this to a lot of different ideas that we have. So what number should I put in here to make this correct? There's probably multiple correct answers, but what might be a simple one?
1 million micrograms, there's 1 gram.
For 1 million of these, right? That's 1 million, right? There is 1 gram. So that's just a helpful way to put it into words, okay? Can I say it backwards and it's still true?
Yes.
I think so. For every 1 gram, wow, my handwriting is awesome. There are 1 million micrograms.
Sounds right to me.
Seems legit, okay? Great, so we're basically taking this ratio and putting it into words. Okay, so now, let's try something else. Let's say so we've got this. What if I had, let me do something down here. What if I had 1,545,000 micrograms?
140.
How'd you get that?
For every.
So this for every, I mean, it works here, but now we've got like an in-between number, right? This number is like in between that. Is the for every statement true regardless of how much I have of each one?
Yeah.
Yes.
Because the ratio is the same. The individual amount you have might be different, but the ratio should be the same. Yeah? Let me show, here, let me actually go to the slide bar I have this. Whoa, back up. Let's do this. So let me write this over here. So 1,545,000 micrograms, and I want to know how many grams that is. Okay, so because the ratio is the same, here's what we could do. We could set up a proportion. We could say that if I take this divided by this, I'll just put X grams. If the ratio is the same, how do we show that two things are the same in math? We use what kind of sign? Equal sign. So this should equal my for every statement, but in math. Cross multiply, solve, move things around, do your math magic, solve for x, yes? Wave my hands, do my math magic, x equals 1.545. See that? So from the graph, we saw that we had a consistent ratio. We can put this ratio into words, and we realize that no matter what my individual amounts are, the ratio should be the same, which is why I'm allowed to set up that proportion.
Would it be easier to put in scientific notation?
That is up to you. You can put in scientific notation, you can do standard notation, it's up to you, okay? Kind of makes sense? Questions? Carson?
Now teachers going to the section.
Yep. Let me set up the next one and then we're almost done. This is my last slide. Might be. Might not. Let's see. Let's see. So we're doing proportions here. I gave us a random problem, but what we can remember is that the ratio of grams or of the units equals the ratio of the stuff I'm trying to figure out. So, I mean, it doesn't really matter which one's on top. If these are equivalent, I can set up a ratio. 3, 4, 8, 9 megameters, right? That's megameters. X meters should equal the amount of meters that are in 1 megameter, right? There's some ratio here. Anyone remember how many meters are in a megameter?
1 million.
10 to the 6, I think is, yeah, a million. So you said the same thing, different ways. Cool. So because of this idea of the ratio being consistent, I can set up a proportion. Right? I got this from the problem, I got this from my notes. Yeah? For every 1 megameter, there are a million meters. For every million meters, there is 1 megameter. Can we solve this problem? Hopefully. X equals Did I do my math right? I did it in my head.
Yes.
Cool. 89.9 meters is the same as 0.0000899 megameters. Okay, so when I give you a conversion problem, a proportion is a familiar way that you can solve that problem. Okay? Now, normally teachers skip straight to the thing called a picket fence. You guys remember picket fences? Anyone? No? Okay. So picket fences they're probably called different things for different teachers. This is the quickest way to do it, but this is the way, so most teachers will skip to what I'm about to show you, but it looks really weird and it's confusing, and then because it's not connected to other ideas, kids freak out and then they forget it, okay? So I'm leading up to this. I would like you to use the picket fence, which is what I'm about to show you, but I wanted to build up to it so it makes more sense, okay? So let's take these exact same problems and just rearrange them in a way that's easier to use, okay? So let's say, let me rearrange this and solve for x, okay? So if I rearrange this, x equals, everyone see what I did? I rearranged it. So if if I cross multiply, I have an x times a million and then 1 times this. So I could have 1 gram over here and my x grams over here. And then if I want to solve for x, I can divide the million over. So this times 1 over a million equals x. This times 1 over a million equals x. See that? Okay. So now here's why this is easy. Check out what I have to do. All I need to do to solve this problem is take what I'm given and multiply it by the ratio of the units I'm converting between. Yeah? And all I need to do, and then, well, do I put grams or micrograms on top or bottom? Well, I need to set it up where I just cancel out the units that I'm getting rid of. So I'm trying to get rid of this one, I want to get this unit, and so I just leave this unit on top. You see that? If I were to rearrange this one, I can do it by saying x equals, start with what you're given, and just multiply it by the ratio of the 2 units we care about. I'm comparing these 2 units. So then I would go megameters on the bottom and meters on top, because I want to cancel that unit and end up with this unit. See how those units cancel? And there's a million of these in one of those. So that's where I can fill in my numbers. Okay, so what I'm trying to show you is that this is the same as this, but if we think about it in this picket fence way, I'll show you why it's a picket fence in a second. If we think about it in this way, it can be faster, okay? Now, can you solve it this way and get the same answer? Yeah, okay. But this will eventually become quicker, especially when we get multi-step problems, then it'll go faster that way. Okay, questions? Can I show you the next slide? We do some examples? Okay. What's NS? How many nanoseconds is equivalent to 0.0034 seconds? If I wanted to do the proportion, I would do, here I'll do x nanoseconds over this, 3-4 seconds, equals whatever my relationship between nanoseconds and seconds is. Right? The picket fence way is I take what I'm given and I just multiply it by a fraction, okay? And to be lazy, instead of doing parentheses, I'm just gonna do this. There, so now it looks like a fence. Okay? And I wanna cancel this unit away. So I'm gonna put seconds here and nanoseconds on top. How many nanoseconds are in a second?
1 billion.
Billion?
A billion. Okay, and if you forget, it's from your notes.
Oh, it's not negative.
So that would be, there's 10 to the negative 9 seconds in 1 nanosecond.
Oh, okay.
So. I mean, it would work out the same. The math would work the same. So I can solve this proportion, or I can take, multiply by that, divided by that, and you should get the same answer. Yes? So I get, what's my answer?
3,400,000.
So that,
Yeah.
10 to 6.
nanoseconds. Cool. Okay, I'm gonna skip this one. Let's do this one. Okay, this one has a prefix unit and a prefix unit. Everything we've been doing so far involves a base unit. Okay, but now we don't have a base unit. Okay, so we should do this one in 2 steps. Okay, we should do this one in 2 steps. So what I should do first is I have milligrams, right? What you should do is go to the base unit first and then go to the next prefix unit that you're given. Okay, so if I wanted to do a proportion, I would have to do 2 proportions, right? I would have to do a whole proportion to get to grams, right? Do a ratio with grams, and then I would have to take those grams and I have to do another proportion to get to picograms, okay? So proportions can be nice, but they're clunky and they take a long time if there's multiple steps. This is where the picket fence is really nice, because what I can do is I can just take what I'm given, and I can multiply it by my ratio to give me grams. And then I can multiply that by the ratio that gives me picograms.
I did not realize that was called a picket fence.
I don't know, I feel like it's kind of a janky name to call it, but that's what I call it.
Okay.
Some people call it dimensional analysis, but yeah, picket fence is great. We're farm people here, we know what picket fences are. Okay, so I want to cancel this unit. So I'm going to put it down here, right? We're getting rid of it. And I'm going to grams. What's the ratio of grams to milligrams? 1,000 what? In what?
1,000 milligrams is 1 gram.
1,000 of these in one of those. Okay, so pay attention to that. You'll notice the bigger unit has 1 and then the smaller unit has more of them. That's how we'll do it. Okay, so then for this next step, I want to cancel the grams and I want my picograms. 1 gram and a trillion picograms. Make sense?
Yes.
Now you could have done 2 separate proportions where I do a proportion, get to grams, do another proportion, get to picograms. You'll get the same answer, but this is so much faster. Now I just do this, times this, divided by this, divided by this. And that's how you multiply fractions, okay? And if you want to skip multiplying by 1 and skip dividing by 1, I would recommend it because that doesn't change the number, right? So what's my answer?
8.45. Is it 10 to the 8 or 10 to the 10?
It's going to be,
'Cause you'll
I
subtract-
can't math in my head.
You'll subtract 3 and 12 and 9, but that's 20.
Someone use a calculator and double check me. Can someone do the math real quick?
Because you'll subtract the 12 and 3. and
Right, so it's like this
0.8,
times 10 to the
But
9.
it's 0.8, so then if you move it over, it doesn't have to subtract.
I think it's 10 to the 8. Okay, Shree agrees with me. We'll go with that. And then don't forget your unit. I get grumpy if you don't put the unit. Picograms. We okay?
Wouldn't it add it though, because you're going from a larger unit to a smaller unit, meaning you have more in that smaller unit?
Yes. I mean, this compared to this, right?
Yeah.
That's more than what that was.
So then you'd add and have 10 units.
Hold on.
Yeah.
0.845 times. Oh, I can't even do that. Times 1, 2, 3 divided by 1, 2. 8. 10 to the 8. That's what I said. Okay. How much time do we have? A little bit of time.
17.
Okay. Should we do some practice?
Yeah.
Let's do some practice in partners, okay? I like to give us an opportunity to help each other, okay? We'll make this easy, okay? Partners are next to you. Partners next to you. I'll do you 2 partners, and then I'll do representing Benton Partners and Carson and Kairos Partners. Cool? Okay, so I'm gonna give you 10 problems, okay? I would like us to do this in a structured way, okay? So this is an activity, it's called Rally Coach, okay? Rally means to, coach means you help each other, okay? I didn't make this up, but I think it'll be helpful, okay? 10 problems, divided by 2 people. How many does each person do?